Welcome to solverfy.
Okay, so in first part of this problem, we have to balance the combustion reaction um, between the propane and oxygen. So here is the reaction of the combustion of propane, and to balance this reaction, we'll first write down each of the species present on both sides of the reaction equation. We have carbon, hydrogen, and oxygen in each side. Okay, now we will write down the number of each atom or element present. So we have 3 carbon, we have 8 hydrogen, and 2 oxygen in the reactant side. And the product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. So first we'll balance the number of carbons. So we have 3 carbon in the reactant side, but we have 1 carbon in the product side. So we will place a 3 here to get 3 carbon in the product side also. Now we have 3 carbon in the product side, but at the same time we are multiplying the number of oxygen, and now we have 3 times 2 means 6 plus 1, 7 oxygen. We have 7 oxygen in this side. Now we have to balance number of hydrogen. So we have 8 hydrogen in the reactant side, but we have 2 hydrogen in the product side. So what we will do, we will place a 4 here to have 8 hydrogen. 4 times 2, 8 hydrogen in the product side also. Now we have 8 hydrogen in the product side, but at the same time we are multiplying the number of oxygen also. Now we have 4 oxygen plus 3 times 2, 6. In total we have 10 oxygen in the reactant side, now in the product side. That means we need now 10 oxygen in the reactant side also. And to have 10 oxygen in the reactant side, we can just place a 5 here to have 5 times 2, 10 oxygen. So now we have 3 carbon on each side, we have 8 hydrogen on each side, and we have 10 oxygen on each side. That means this is the balanced equation for the combustion of propane. Now in the second part of this reaction, we have to say, looking at the diagram, what is the limiting reactant here. So as we know that the limiting reactant is the reactant which will be consumed completely in the reaction and which will be consumed first in the reaction. So from here uh, we can identify that these red circles or spheres, and we have two of the red spheres joined together. From here we can see that this is our oxygen, and these black and white spheres should be our propane. So from here we can see we have 3 propane, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen. So we have 3 propane and 10 oxygen. So from the balanced equation, we can see 1 propane will react with 5 oxygen. That means for 3 propane, we need 3 times 5, 15 oxygen we need. We need 15 oxygen, but we have 10. That means in this reaction, the oxygen will be consumed first or consumed completely first. And that's why oxygen is the limiting reactant here. Once again, as we have said, that the limiting reactant is the reactant which will be consumed completely first in the reaction. And from here we can see, for 3 propane we need 15 oxygen, but we have 10. That means 10 oxygen will be completely consumed at first, and that's why oxygen is the limiting reactant. Now, in the uh, last part of this problem, or in part C, we have to say, after complete reaction, how many molecules of each reactant and product we will have. So if we write down the number of um, each reactant and product we have initially, this is initial and change and final. So initially, from the picture we can see we have 3 propane and we have 10 oxygen, and initially we don't have any carbon dioxide or water. That means that will be 0. The changes, so as you have said, the limiting reactant will be completely consumed. That means the change in oxygen will be 10. That means uh, all the 10 oxygen molecule will be consumed, and this 10 oxygen will react with 2 propane. Since one propane react with 5 oxygen, one propane react with 5 oxygen, that means with 10 oxygen 2 propane will react. That means the change in propane will be minus 2 and change in oxygen will be minus 10. Now, what will be the change in carbon dioxide? So one molecule of propane can produce 3 molecule of carbon dioxide. That means 2 molecule of propane will produce 2 times 3 means 6 carbon dioxide. So the change for carbon dioxide will be plus 6, and 1 molecule of propane can produce 4 molecule of water. That means 2 molecule of propane will produce 2 times 4 or 8 molecule of water. That means the change for water will be plus 8. Now the final number of molecules, um, or the final number of so the final number of molecules for propane will be 3 minus 2 1. We can write it in another, so for the propane it will be 1, and for oxygen 10 minus 10 is 0. That means no oxygen will be remaining in the reaction mixture. And since the number of carbon dioxide produced is 6, so the final number of molecules for carbon dioxide will be 6, and the final number of molecule of water will be 8. So the answer to this question is, in the final or the after the reaction completion, we will have 1 molecule of propane remaining, we will have 0 molecule of oxygen, 6 molecule of carbon dioxide, and 8 molecule of water remaining, or will be present in the reaction mixture.